All right, pre-calc. We're going to do some heavy lifting today. So if you need to take a break in this video, not yet. Come on, not yet. You might want to do that. All right, this, my friends, is the unit circle. This is the next thing we're going to be studying. We're going to try and point out every pattern and every trick that we know. That way, this is as stress-free as possible. But there are a couple things that we need to figure out what's going on here. So um, we're going to give you all the tricks that we have. And the first thing we need to know is the radius. The radius is always going to be 1. So we're going to apply this into 30, 60, 90 triangles, 45, 45, 90 triangles. And I'm going to try and point that out first. That way all these numbers seem to make sense. Okay, and then we're also going to point out a couple other acronyms and some things to make this a little bit easier. All right, but what I hope you notice is once we fill in part of it, we can find out the rest of it, right? Because we have some reflections. Right? So that's what this ASTC stands for. Okay, so some will say all students take calculus. Okay, add sugar to coffee. I don't care which way you want to remember it. There's some other ones out there too that we can't really say. But that just tells us about what's going on as we look at this. So the ordered pairs that we see, right, this is our 30-degree reference angle. Okay, so this is going to be cosine and then sine. How do I know that? It's in alphabetical order, right? X, Y, cosine, then sine. So of course I can take the ratio of those sine divided by cosine being the y's over the x's so I can find out what tangent is. And that's pretty much as far as we're going to go with that. But today my focus is for you to understand where these numbers came from and how to deal with that. All right, so we're going to focus on the first quadrant. So the first thing we're going to do is just this 30-degree angle. So I got some angles over here, and what I did is I pre-labeled a couple things. All right, so my 30-degree angle, so I know this must be x, so the hypotenuse is 2x, and I know the 60-degree side is x root 3. But here's the thing that you were given. You were given the fact that the radius is 1. Let's see if this orange shows up. There we go. All right, so as we solve and work our way back here, we'll find out that if that's 1, then x over here must be what? It must be 1 half. So this must be 1 half of root 3. Well, I'll put that over 1, so this is root 3 over top of 2. Okay, now what I need is cosine first, and that's going to be your x coordinate, right? So as I look here, right, my x coordinate is then going to be the square root of 3 over 2, and the y coordinate, notice I'm going up 1 half, is 1 half. Okay, so that means over here at 30 degrees, I can fill in root 3 over 2, comma, 1 half. So it's cosine of 30 and then sine of 30. Okay, so we'll try and make all that make sense as we move forward here. All right, the next one we have 45-degree angle. Remember, the hypotenuse has to be 1. But as we know about 45, 45, 90s, right, this is my 90 here, is I must have x as the side, so x root 2, but x root 2 is 1. So how do we work backwards out of that? Okay, so that means x root 2 has to be equal to 1, so we're going to divide by root 2, and we're going to fix that. So it becomes root 2 over real 2, and that gives me my cosine of 45. Turns out to be root 2 over 2. And you know what sine of 45 is going to be then? Well, they're the same, right? So root 2 over 2. So if I drive over here and say, all right, that's 45. So root 2 over 2 and root 2 over 2. I should have made this a lot bigger. All right. And then in our last one, so we're going to take that 30, 60, 90. The radius is still 1 right here, guys. So what I have to do is kind of flip everything around. So what's going to happen as we go to solve it, we're going to find out that we have, 2 here. That should be, so the 1 has to be 2. So that means we're talking about 1 half down here. I get too many things labeled here. All right, so if that's x, this should be 2x right here. Okay, guys, so if you're trying to fill it in the way I have it, right, because we had x, we had 2x, we made x root 3. All right, so what happens is if the hypotenuse is 1, then this side over here, so cosine of 60, well, that's going to be 1/2. Well, we know what's going to happen here. This is 1/2 times root 3. And put that over 1, so root 3 over 2. Root 3 over 2 is going to be the sine of 60. All right, so let's go fill that in. So this is our 60 degrees, and this is going to be 1/2, and then it's root 3 over 2. Okay, well, we missed a couple things here. What's the ordered pair to get started? Well, if the radius is 1, that means x is 1 and y is 0. And just the opposite over here, right? 0 degrees, or this could be 360 degrees. And then up top here, what we have going on is we've now gone 0 on the x-axis, 1 on the y-axis, and you guys know we're at 90 degrees here. Okay, so I have a couple other things to fill in, and that's going to be about radians. So we can use the idea that we know that 2 pi equals 360 degrees. We can use pi is 180 degrees. So we know that 90 degrees is half of that, so it's pi over 2. We know that this is either 0 or 2 pi. But for the ones in between, I want to give you a way to count through that. So I just want to leave it at that. So that's how we use those. Now, those have all been given and prescribed for you, and we really shouldn't have to like figure this out again. But I wanted to show you where it comes from because I think that's important as we try and move forward here. So the next thing I did is I get a couple unit circles for you, and I just want to fill these in. We're going to fill in the 45s by degree, and then we're also going to fill in those sections by radians, right? So these are going to go together to make this a little bit easier. So here we go. So I know this is my 0 degrees, or it could be 360 degrees. Okay, so notice I'm not going to fill in the ordered pairs this time, make this a little bit easier. Okay, so this, I'm going to go to the quarters first. So 90 degrees, 180 degrees, 270 degrees, 0 and 360 degrees. All right, so then what we do, since this is by 45s, so that's really the quarter of everything. So that's important to think about. So that means 90, this should be 45 degrees. And then what we have is 135 degrees, right? Because that's the quarter. Then we're going to end up at 225 degrees. And then over here, we're going to be at, we already had the 270, and we're at 315 degrees. Okay, so that's by quarters for our degrees. Now, the other part that we have listed in here is then the radians. The radians. So we're going to fill in our radians. So we know this is 0, or this is 2 pi. We know that this is pi over here. And those are kind of our starting points and everything that we're going to work with. Okay, so we know if this is pi and this is 0, this must be half of it. All right, and if that's half of it, then half of a half is a quarter. Okay, so again, we keep coming back to this idea of quarters. So here's what's really going to happen. The way I would like you to really deal with this is remember that as we deal with all the 45 marks, we're going to say we're going to count by quarters. Okay, so here's how it works. This is 0/4. This is 1/4. But notice it's in radians, so I'm going to deal with pi. That's what we have. Now, what would this one be? This would be 2/4. So I made it, I'm going to keep adding pi on as I count by fourths. So that means we made it 1/2 of pi. So what do I have here? This is 3/4, and I have pi. So this one is going to be 3/4 pi. Okay, and what would this be? This would be 4/4, which just turns into 1 pi. We keep counting. This is 5/4. So we're going to keep it that way. 5 pi over 4. This would be 6/4, but we don't use 6/4, right? We use 3 pi over 2. So in one sense, it seems really weird, but then when you start just counting it, since these break everything up into quarters, count by quarters. 7/4 pi. And then when I get back over here, we had 0. We're like, well, but it's also supposed to be a 2 pi. Well, wouldn't that be 8/4? Okay, so we find out that those are the same. Okay, so that gets us through the 45s and also through the radians to get where we want to be. All right, so I have another one. There's always another one, right, guys? So this time we're going to go by the 30s. We're going to count by the 30s. All right, so first things first, let's just fill in the degrees as we normally would. So I got 0 degrees or 360 degrees. I know it's a little bit repetitive, but just bear with me here. So we know we have 90 degrees, we have 180 degrees, we have 270 degrees. I don't know why I didn't highlight that one. I'll add that in now. Here we go. And what we had is 30, 60, 90. What do we have to? 120, 150, 180, 210, 240, 270, 300, 330, and 360. You're like, all right, Mr. Tola, I made it to pre-calculus. I can count by 30s. Enough already. You know what I'm saying? All right, so the next thing we want to do is just take a look at it and see how it's divided up. And what I hope you notice is that it's divided up in 6. So here's what we're going to do. We're going to count our way around now to fill in the radians. All right, we're going to fill in our radians. So we know this is 0 or 2 pi. Right? So some of these you just know because we've been dealing with them so much. Okay? But that's where we're going to start. So 1/6, 1/6, 2/6. Okay, because I'm meeting up with those. Now we won't see 2/6, will we? We're going to see pi over 3. 3/6. Well, we already knew this one was pi over 2 because we covered in the quarters. But notice I'm going to keep it here because I do count by the 30 as well to get there. 4/6. So this is 2 pi over 3. 5/6. So we'll keep it. 6/6. So this is kind of a point to make sure we're at the right place. Isn't that just pi? Okay, so 5/6. I almost forgot to mark this one in here. You can mark it inside or outside. Just make sure if you leave it on the outside, I'm trying to leave it so you see that we're just counting by 1/6, but we do want to have it reduced. So 7/6 is good, 8/6, and maybe that's what I should do. Just say 9/6 and then go back and reduce the ones that need it. 10/6, don't forget your pi. 11/6 and 12/6. Oh wait, that's supposed to be 2 pi. Cool, we got it. All right, so what I did is I kind of hurried through there and I didn't reduce some of these. So I do have pi in here. I left that one in. Let's see, 7/6, that's going to stay that way. 8/6, that's going to be 4/3. 9/6, well, that's 3/2. And 10/6, that's going to be 5 over 3. 11/6, keep it. And then 12/6, we have it. Okay, so I want to provide a couple different places to have that. Obviously, you know, we could overlap these and put one right on top of the other because that's what we want for the entire unit circle is for how those things go together. All right, so here's what we have to do. We have to put the idea of not only the degrees, the radians, but also the ordered pairs. And then what we're going to do is notice a couple things. And so if you have one all filled out here, let me show you what's going on. So we focused on just the very beginning. Okay, in the very beginning, we focused right here in the first quadrant. And what I've done now is I've highlighted some of these. So you can go back to the top of your unit circle and add this in if you want to. But I just want you to notice that this is where the all students take calculus comes in. And what this has to do with is the signs. Okay, so as I look at the signs of my ordered pair, everything is positive. Okay, remember it's cosine and then sine. Maybe I should have that on here as well. Cosine, comma, sine. So I look at these. These are x values and y values. They're always positive because we're in the first quadrant. We're like, yeah, no duh, right? And then I get over here, and what happens over here is now all students. So this is sine is going to be positive because all my cosine is negative. Okay, so if we talk about what quadrant we're in, we should already know what the signs are supposed to be. No pun intended with sign. So t, so this is tangent, right? So tangent's going to be positive. Why is that? Because both sine and cosine are both negative, right? So the ratio of them, at the y's over the x's, so sine over cosine, negative over a negative is going to be positive. And then the last one is, of course, the cosine, which is your x values again. Okay, so x value is positive. So that helps us identify what's going to be where. All right, now you're thinking left hand fingers, the square root of fingers divided by 2. What in the world is that? All right, so we're going to try and keep this in front of you. And you know what? There's a lot of stuff on here. I'm going to scroll up. Sorry about that. Sorry if that makes you dizzy. All right, here's how it works. Let me get rid of the radius as 1, and let's deal with it. All right, so you can take your left hand and you're going to hold it out like this. And what I'd like to know is 30 degrees, right? 30 degrees. So we're going to take this finger out. We're going to take this finger out. And the top of your hand, this is why we have to use your left one, is cosine and then sine. So the top of your hand, you have 3 fingers. Okay, so 30 degrees, because we took out that finger, right? So cosine of 30. So now I have square root of 3 over 2. And what's on the bottom is 1 over 2. Holy cow, look what it's supposed to be. You're like, wow, that's just crazy talk. That can't be the way all the time. Okay, so let's take a look at the next one. Let's say that we're going to talk about, all right, so what's the ordered pair for 60 degrees? So I'm going to take this one out, right, because that's my 60 degrees, right? 0, 30, 45, 60, 90. Right, so what's on top is my cosine. Cosine, square root of 1 is 1 over 2. On the bottom, this will give me my sine, 1, 2, 3. Okay, so square root of 3 over 2. Well, look at that. All right. I'm like, well, that can't work. I'm like, all right, well, it's kind of working so far, isn't it? Yeah, this is a proven method. Okay, so I'm going to stop fooling around like it doesn't work. Okay, so let's talk about 45 degrees. So I get the square root of 2 over 2 along with the square root of 2 over 2. So I'm scribbling that finger out, but you should actually be practicing by looking at your hand. Okay, I know we said don't use your hands in math, but now I'm saying use your hand. Right? There's no reason to try and memorize this. What we're doing is we're trying to create a device so you can find these reference angles super easy. You're like, that's great, all, Mr. Vitola, but what about 0 and 1? How do I figure that out? What if it's supposed to be? How do I figure 90 degrees? Well, just take out 90 degrees. So on the top end of your hand is what? 0. So 0, square root of 0 over 2 is going to be 0. Well, that gives you your cosine. And what do I have down here? I've got the square root of 4 over 2. Okay, so I have 2 over 2. Well, that turned out to be 1, and that's what we have, 0, 1. Okay, so you just have to make sure that if it takes away the top half of your hand, then it does turn into 0. Okay, and it will work the same thing the other way to try and get that 1, 0. Right, if we took this one out, we would flip-flop that. So we have the 4, so 4 over 2, so this will give you a cosine as we change the angle here. And then we would get the bottom half of my hand becomes the 0. All right, so those are all the tips and tricks. All right, so here it is labeled in here. All students take calculus. Okay, and again, the tangent is going to be the ratio, right? Remember this just like slope, the y over the x. And since we know that cosine and then sine go in alphabetical order, that means it should be sine being your y over top of your cosine as we look at those. Right? So this is kind of your job right now, is just to figure out which way you can put all this together. And then we're going to just practice like crazy until we kind of have it all figured out. And it's almost like learning a second language. So that's what we're working on here. So we could easily say, okay, well, what's sine of 30? So sine of 30 is going to be 1/2. How do we know that? Because it's the second half, right? And we can see that it's going to be 1/2 there. So it's kind of a chain of events that you want to have memorized. So sorry for the longer video, but I just didn't want to skip any part of this because it all goes together. All right, we'll keep working on it, and I'll see you in class.